Across frozen forests, open-pit mines, and construction sites on every inhabited continent, these machines bear a name that commands quiet authority in heavy industry. Volvo. Not the biggest maker of construction equipment, not the cheapest. But to the operators who spend thousands of hours in their cabs, perhaps the most trusted. A global machine empire, forged on a philosophy of durability, safety, and operator comfort that the rest of the industry would spend decades trying to replicate. It all traces back to a single Swedish iron town and a workshop founded in 1832. In 1832, Eskilstuna's workshops rang with the sounds of hammers and steam, as Johan Theofron Munktell, a pastor's son turned self-taught mechanic, opened Munktell's Mekaniska Verkstad. The town, already known as Sweden's Iron Town, was a magnet for skilled tradesmen and apprentices, drawn by municipal tax breaks and the promise of water-powered machinery. Local leaders, eager to modernize, set the stage for a culture where engineering was both craft and calling. By the 1860s, Jean and Carl G. Bollinder, Swiss-born brothers, brought new precision to Eskilstuna. Their firm, J and C. G. Bollinder, quickly earned a reputation for pistons and pumps, and later for robust diesel engines. Supplying the Swedish Navy and the State Forestry Board, Bollinder's works forged close ties with national institutions. Both the Munktell and Bollinder families became fixtures among Sweden's technical elite, exchanging patents and shaping the early Swedish Technical Association and the Royal Swedish Academy of Engineering Sciences. As Sweden shifted from an agrarian society to an industrial force, Eskilstuna's technical school, later the Royal Institute of Technology, produced a steady stream of draftsmen and machinists. Workshops doubled as classrooms, blending apprenticeship with hands-on experimentation. This practical approach, testing ideas in real-world conditions, became the hallmark of Swedish engineering. Innovation was measured by what survived the field, not just the drawing board. By the early 1900s, Munktell's shop had branched into tractors and steam engines, while Bollinder's diesel expertise opened new markets in forestry and agriculture. In 1932, as economic pressures mounted, the two firms merged to form AB Bollinder Munktell. The Swedish Ministry of Industry encouraged the merger, offering low-interest loans, while Eskilstuna's City Council granted BM a lease on the old Munktell shipyard, critical for exporting heavy machinery. Labour relations, rooted in collective bargaining with the Swedish Metal Workers' Union, helped ensure a smooth transition and steady production. BM's first major product, the BM 400 tractor, debuted in 1934, built for Sweden's rugged forests. Early marketing highlighted its ability to haul timber from remote stands, reflecting the constant feedback between field operators and engineers. Each design was shaped by practical experience, reinforcing a culture where reliability was a necessity, not a slogan. In 1950, Volvo AB, already a force in cars and trucks, acquired a controlling stake in BM. The deal, financed by retained earnings and backed by a state export credit guarantee, echoed Sweden's industrial policy of building strong, integrated companies. BM's integration into Volvo's structure laid the foundation for Volvo construction equipment. This was more than a merger of assets. It was the fusion of engineering philosophies, labor traditions, and institutional support. The DNA of Volvo's machines, durability, safety, and operator focus, was forged in these early decades, shaped by municipal ambition, state policy, and the relentless drive for practical innovation in Eskilstuna. A machine's legacy is measured in the burdens it carries and the trust it earns from those who rely on it. In 1913, Munktell's workshop in Sweden produced the nation's first tractor, a rugged machine built for the Nordic landscape. Its cast-iron crankcase and ladder-frame chassis made it tough enough for remote fields. Farmers valued the clutch brake system, which let them change gears without a gearbox, reducing breakdowns and making repairs possible with basic tools. Many of these tractors ran for decades, their longevity quietly establishing a standard for practical durability. The BM 400 tractor, launched in 1934, brought these values into the forests. Its reinforced steel frame and safety cage around the rear axle were designed for timber work, hauling heavy loads over rough ground. Unlike other tractors of the time, which left operators exposed, the BM400's protective features reflected a new idea: machines should look after their operators. Swedish forestry crews, working through harsh winters, depended on the BM400 not just for its strength, but for the safety it offered in dangerous conditions. By 1938, as Sweden's infrastructure ambitions grew, the L20 wheel loader arrived. Volvo BM introduced hydraulic lift cylinders and a semi-closed hydraulic system, allowing the loader to keep working even if the main pump failed. This redundancy was not a luxury. It was essential on remote road sites where downtime could mean days lost. The L20's single-piece, high-strength steel frame absorbed shocks from stone and frost, and its 1.5-ton bucket sped up roadwork. Reports from the era called its dual-mode operation a breakthrough, letting crews keep working when others had to stop. The post-war years brought new machines for new demands. The H20 excavator, introduced in 1948, featured a welded steel lattice undercarriage for rigidity and a boom forged from high-tensile alloy. Its dual-pump hydraulic system, one pump for lifting and one as backup for swing control, embodied a philosophy of mechanical redundancy. In a 1951 field trial at a Swedish limestone quarry, the H20 logged over 2,000 hours with only minor hydraulic leaks, setting a new reliability benchmark. By 1952, the H30 excavator pushed these advances further. Its closed cab with a dual-glass safety windshield protected operators from dust and falling debris. A thermostatically controlled cooling fan kept the engine safe during long shifts, eliminating the overheating that plagued rivals. The H30's 1-ton bucket boosted productivity, while its safety and comfort features reduced fatigue and extended shift lengths, a direct translation of Scandinavian engineering values into daily work. Each of these machines, from 1913's first tractor to the BM400, the L20, the H20, and the H30, embodied material resilience, mechanical redundancy, and a commitment to operator safety. Their quiet, enduring performance forged Volvo's reputation across farms, forests, and the infrastructure of a modernizing nation. The rise of the L-series wheel loaders signaled a new era in Volvo's approach to construction machinery, one defined not by size or spectacle, but by a relentless pursuit of practical excellence. In 1971, the L70 debuted with an articulated steering joint, a technical leap that transformed machine maneuverability. The articulation joint, engineered with a double cardan shaft and spherical bearings, allowed the loader to pivot smoothly through tight construction sites and forest trails. This innovation did more than improve turning radius. It gave operators a sense of control and stability that set a new benchmark for the industry. By 1975, the L80 introduced refinements to the cab environment. Engineers elevated the operator's seat, widened the visibility arc, and incorporated vibration damping mounts beneath the cab floor. These changes responded directly to field reports from Swedish road crews who worked long hours in harsh conditions and needed relief from the constant jarring of earlier machines. The result was a loader that not only moved material efficiently, but also protected the health and focus of its operator, with a new emphasis on comfort. The evolution continued with the L90 in 1979. Here, Volvo's focus on serviceability became clear. The loader's engine bay featured quick release panels and centralized grease fittings, allowing routine maintenance to be completed in minutes rather than hours. The lift arm geometry was further refined, using high-strength steel and optimized pivot points to increase breakout force without sacrificing longevity. Each modification was tested in the field, with feedback loops connecting mechanics, operators, and engineers, an institutional practice rooted in Volvo's Swedish heritage. A decade later, the L150 arrived in 1985, equipped with a hydrostatic transmission and electronic monitoring systems. The cab, now fully climate-controlled, included adjustable suspension seats and ergonomic joystick controls. Operators reported lower fatigue and higher productivity, a direct outcome of design choices that prioritized human comfort and machine responsiveness. The L150's hydraulic system, with variable displacement pumps, delivered smoother motion and reduced fuel consumption, a critical advantage as environmental and economic pressures mounted across Europe. In 1992, the L250 expanded the series into heavy-duty territory. With a raised cab floor and panoramic glazing, the loader offered unmatched visibility and a commanding view of the worksite. The lift capacity grew to meet the demands of mining and large-scale infrastructure. Yet the emphasis on operator experience remained central. The L350, introduced in 1998, pushed these boundaries further, incorporating advanced electro-hydraulic controls and a reinforced articulation joint rated for extreme duty cycles. By 2007, the L350H represented the culmination of decades of incremental progress. Its electro-hydraulic boom system enabled precise load placement, while a new energy recovery feature began to address the growing call for fuel efficiency and reduced emissions. Across each generation, the L series did not simply add power or size. It embodied a philosophy where every technical leap served to deepen trust between machine and operator. This lineage, stretching from the L70 to the L350H, became the backbone of Volvo's global reputation. Machines known not only for their engineering, but for the loyalty they inspired among those who relied on them day after day. Volvo's engineering doctrine is built on 5 pillars, each shaping the machines that bear its name. These are not theoretical ideals, but mandates forged in the realities of job sites and refined through decades of design. At the foundation stands operator comfort. Adjustable, air-suspended seats, climate-controlled cabins, and low-vibration frames are standard. In Volvo's labs, engineers use motion capture and biometric sensors to study fatigue, posture, and reaction time. Every lever and pedal is positioned for natural reach, reducing strain and sharpening focus. This attention to ergonomics is rooted in the belief that a comfortable operator is a safer, more productive one. Safety is institutionalized through in-house protocols that go beyond industry norms. Volvo's rollover protective structure, ROPS, is tested in dedicated labs, where each cabin must withstand a dynamic impact of 35 kilonewtons at a 30-degree angle, meeting ISO 16328-4. Unlike manufacturers who rely solely on external certification, Volvo engineers subject every prototype to repeated stress, recording deformation and energy absorption in detail. This protective cell has saved lives in the field, setting a standard that predates regulation and continues to evolve. Fuel efficiency is engineered into the hydraulic core of every loader and excavator. Volvo pioneered load-sensing hydraulic systems, first appearing on the L120 in the mid-1990s. These systems monitor real-time demand, adjusting pump output to match the precise force needed for each movement. Modern hybrid models cut diesel use by up to 30%, with energy recovery features that capture braking force and return it to the hydraulic circuit. This approach answers the dual demands of lower emissions and lower operating costs, balancing environmental responsibility with economic necessity. Durability is expressed in every weld and bearing. Volvo's design language, clean lines, robust steel frames, muted colors, reflects a Scandinavian ethos that values resilience over ornament. Components undergo endurance testing at the Arvika campus, including freezing cycles, salt spray, and relentless vibration. Only assemblies that survive months of simulated abuse are cleared for production, ensuring that field failures are rare and predictable. The final pillar is a service philosophy grounded in practical maintenance. The grease bank system, introduced in the 1990s, centralizes lubrication points into a single sealed reservoir. Routine servicing takes under 10 minutes, minimizing downtime and extending component life. Service handbooks specify intervals and provide clear diagrams, reducing the risk of missed maintenance and empowering operators to keep machines in peak condition. This approach is about more than ease of service. It is about trust, a recognition that every hour lost to downtime is a cost borne by those who rely on these machines. These 5 pillars – comfort, safety, efficiency, durability, and service – form the standard by which every Volvo innovation is measured. They are the institutional DNA of a company committed not to scale or price, but to enduring value for those who operate and maintain its machines. On a construction site, every hour of UP time counts. For a fleet manager overseeing dozens of machines, the choice between brands is not simply about purchase price or horsepower. It is about the total cost of ownership, measured over years of relentless use. Volvo Construction Equipment has built its competitive edge on this principle, setting itself apart from giants like Caterpillar and Komatsu, not through scale, but through a doctrine of lifecycle value. The foundation lies in the numbers. Telematics dashboards, now standard in modern fleets, capture every minute of engine run time, idle hours, fuel consumption, and unscheduled maintenance. Data from Volvo Connect, the company's proprietary fleet management platform, shows that Volvo loaders and excavators routinely achieve a mean time between failures of 1,500 hours, outperforming industry averages by a notable margin. This reliability translates into a 95% median availability rate over 3 years, as confirmed by independent uptime indices. Such consistency is not accidental. It results from engineering choices that prioritize serviceability, material longevity, and operator well-being. Lifecycle cost analysis reveals the practical impact. Over a 10-year horizon, Volvo machines report a 5 to 10% lower total cost of ownership compared to Caterpillar or Komatsu, driven by reduced fuel use, fewer breakdowns, and shorter maintenance intervals. Predictive maintenance, powered by real-time telematics, alerts fleet managers to component wear before failures occur, allowing for planned service rather than costly downtime. Operators, too, report measurable benefits. Ergonomic cabs reduce fatigue, while intuitive controls and safety systems lower the risk of incident and injury. For decision-makers, these numbers are more than statistics. They are the basis for trust. In a field where every lost hour carries financial weight, Volvo's approach ensures that machines remain productive, safe, and comfortable throughout their service life. This is the quiet but decisive advantage that underpins Volvo's reputation among those who measure value not in sales figures, but in dependable performance day after day. At the edge of Sweden's forests and quarries, the future of construction is taking shape in 3 centers of innovation: Arvika, Gothenburg, and Lindesberg. Here, the quiet discipline of Swedish engineering meets the demands of a changing world. In Arvika, test grounds stretch across 75 hectares, where electric wheel loaders endure months of simulated abuse, freezing cycles, salt spray, and vibration, until only the most resilient designs remain. The modular battery system developed for the L25 Electric allows a depleted pack to be exchanged in under 15 minutes, eliminating the downtime that once defined heavy equipment. Each battery module is sealed and shock-mounted, a direct answer to the rigors of mining and demolition sites. In Gothenburg, the Research and Development Center houses the prototypes that will define the next era. Autonomous haulers, guided by sensor fusion, integrating LiDAR, radar, and GPS, navigate obstacle courses without a driver. Engineers monitor real-time data feeds, adjusting algorithms to handle rain, dust, and shifting terrain. The Autonomy Trials Zone is not a showcase. It is a living laboratory where every misstep becomes a lesson and every hour of safe driverless operation is a step closer to deployment in copper mines and remote quarries. Lindesberg's assembly lines produce the L350H electric loader, a machine whose reinforced frame and adaptive hydraulics are tailored for sector-specific challenges. In ports, it moves containers with millimeter precision. In forestry, it handles timber on uneven ground. The adaptability stems from decades of field feedback, but also from a series of acquisitions: Ackermans in 1991, Champion Road Machinery in 1997, and Samsung Heavy Industries Construction Division in 1998, which brought expertise in excavators, graders, and Asian market adaptations under one roof. Today, Volvo Construction Equipment supplies machines for mining, forestry, road building, ports, and quarries in over 190 markets. Each sector demands its own technical solutions: modular batteries for urban sites, autonomous fleets for hazardous mines, and customized operator interfaces for long-haul roadwork. The institutional drive that began in Eskilstuna's iron workshops now fuels a global enterprise, pushing the boundaries of electrification and autonomy. In these test labs and assembly halls, the next chapter of construction is already underway, shaped by the same values, durability, safety, and human focus that defined Volvo's earliest machines. In an era defined by rapid technological change and urgent demands for sustainability, the world increasingly looks to proven institutions for guidance. Volvo's commitment to operator well-being and enduring engineering now shapes the global transition to electric and autonomous machinery. As infrastructure ambitions expand, the standard set by Swedish industrial values endures, reminding us that true progress is measured not only in innovation, but in the trust earned through generations of reliability.